Hello and welcome to Beyond the Arches. I'm your host, Dr. Daniel Noorthoek. With me, I've got a part two. We've got Patrick, we've got Wes, and we've got Blake with us today. Welcome back, guys.
Hello, hello.
Went a long ways. I think we had one bathroom break, but
Couple waters.
we're back. We're back putting a part two on our discussion, just sort of about dentistry, the full arch industry as a comprehensive look, and sort of screw manufacturing and what an implant company sort of does and looks like. And we kind of put a pause in the last episode because I wanted to talk about more manufacturing data acquisition and what happens beyond the implant screws. And so I felt like that was a good break because this is a whole other topic and category. And, you know, having you on this, Patrick, is great because, like I said on the last episode, you've always been this all-in-one kind of pusher, right? You want the manufacturing side to be available and the data acquisition side and the implant screw to be proper. And that isn't just from most of the time that feels disingenuous. Like when I'm looking at an implant company and they say, well, we're an all-in-one package, all-in-one solution. Most of the time they're just picking up, you know, this piece and throwing it into the shopping cart and saying, well, this is available, whether or not they know how to use it or whether or not it's good for the actual practice. And so what I like about you is you've always kind of come from this 360 perspective, which is necessary and the solution is important. But I feel like you've always done a good job sort of incorporating things that are functional and that work, you know, saying that maybe you don't have a big push towards guides. Maybe you have a solution that's available, but it's not one of your big pushes, which is one of my deep convictions is if you have it, great. And if you don't, or if I don't need it, don't push it on me. You know, I've determined that that's not what I want to do. That's not how I want to treat my patients. And so hearing you say that just sort of reaffirms what I'm saying, which is that all-in-one solution is important, but where it's not necessary, it's not like you've never been like a pushy guy with this product or that product. And I think that that's important for us as clinicians making decisions for the patient, not getting sold on something that's sort of snake oil, if you will.
Yeah. It's interesting because you're right. I'm not pushy about it. I hope our company's not pushy on anything. I mean, at the end of the day, I don't think we talked about it, Blake, but with Wes and I were talking about this yesterday. The best way to describe what and this will kind of circle back to who we are, what we do, and to your point on the 360. So Wes and I were chatting in the car right over from Tampa, and it's the best way to describe who we focus on is who we don't focus on. The general dentist coming out of school that wants to do their first single posterior implant, that is the furthest from a customer of ours. They don't even understand the problems our solutions address. For example, I mean, we have custom strategies in Hyperdent where we can actually bring in the XYZ coordinates from your photogrammetry file into the construction info and how that benefits your milling outcomes. You guys mill wet, I think you told me, right?
Yes.
I love that. That's cutting edge stuff. I mean, you have to have a dry cycle on your centering furnace. There's things you have to do to make sure the outcome is perfect, but it's the best way. It's the most high-end way of doing it. That's not revenue generating.
It's also the cleanest.
It's definitely the cleanest. But
what he's talking about is when you're cutting the teeth out, and we'll talk about additive and subtractive manufacturing. But when you cut the teeth out in a milling machine, in zirconia or plastic, it creates a lot of dust, and you can either do it dry, which doesn't have cooling, or you can do it wet, where it's producing, it's cooling the surface down, and so that's generally the better way to do it because you're not imparting stress of heat, etc. in the material. Sorry.
Yeah, and zirconia is a powder that's highly compressed into a 98 millimeter disc. So it's really a powder. So when you get it wet, it actually turns into concrete when it dries. So your team has to be meticulous about cleaning the machines, which clearly they are. Now, my point here is that if you're a customer of ours and you're not milling wet, and we go to you and say, here are the benefits of milling wet, here are the cons, you have to clean it, you have to be meticulous, otherwise you can freeze your spindle, you can have problems. That doesn't generate any revenue for us. But to your point, back to the beginning, if we maintain integrity as a company or as a professional, as an individual, if we maintain integrity that our goal is to bring value, help change practices and optimize and live in that, it's the cutting edge. It's like, what's next? How can we optimize, level up one more? That doesn't generate revenue, but it's what's best for you and trickles down to being what's best for the patient. So that's what we thrive to achieve. We even tell ourselves our goal is to have the best solution, comprehensive solution for full mouth rehabilitation. And if there's a better product out there, we will still market it, still support it, because that's what's best. Even if we don't sell it and make money, even if we lose business, what's important is that we stay in what's relevant, where the technology is going. So let's get deep, man. I'm ready.
Let's do it. Yeah. So let's talk about manufacturing. Blake, the two types of manufacturing mainly actually, no, let's back up. Let's not talk about manufacturing. I wanted to talk about data acquisition. So Wes, why don't you give us a little bit of a insight on when we're talking about data acquisition, there is a big component of scanning. Do you guys have a scanner, an intraoral scanner available?
We sell Trios.
You sell
we
Trios?
sell a number of them. We sell Shining 3D, but anybody who asks us what we recommend, it's going to be Trios 6.
Okay,
Trios
so
5 is good too, but
I think we have 5. When did 6 come out?
This year.
Okay, then we have 5s.
5 is great.
Amazing.
It's the best intraoral scanner for capturing tissue, even in a bloody, wet environment. It's going to give you the best. Now, Wes could talk about this, but we also developed, for those that do surgery, day of surgery, and they want to capture all the data right then and there, we developed the tissue mapper, which eliminates the need for an intraoral scanner post-operatively. You still need the intraoral scanner pre-operatively. Post-operatively, we can capture tissue using photogrammetry technology, and it could be bloody, wet, doesn't matter. It's going to be a very accurate impression.
And so why don't we talk about that real quick? So in photogrammetry, or not photogrammetry, with intraoral scanners, there's two big ways in dental technology, speaking to soft tissue and implant position, that we're acquiring the data on a patient, right? That is intraoral scanning and photogrammetry. So intraoral scanning is what, Wes?
Intraoral scanning is just you're taking pictures and you're stitching those pictures together of the object that you're scanning.
Like 4 or 5 pictures, or?
No,
2,000.
Is it 2,000?
Yeah, it's usually 2,000 is when it'll max out on a
2,000
Trios.
what per what? It's 2,000 total images. Okay.
Yeah.
So, and then photogrammetry is you're taking a image of the implant placement and it's giving you an XYZ coordination of where those implants are located.
Yeah, so it's just saying where that implant is, correct?
Correct. Yep.
In relation to each other.
Yes.
So you're getting an XYZ coordinate, as Wes mentioned, but then you're getting the relationship to the one next to it, the one across the arch, the one in front of it, to all the ones that have scan bodies and that are captured. Yeah.
And a scan body is something that fits on top of the part that you're trying to capture the location of. And so a scan body, for those that are listening at home, there are scan bodies that you can take intraoral scans of. That's what we primarily see for single implants, because you can scan and stitch those pictures together enough, and the technology or the design, design file software knows enough to get it in a good position where it can then be 3D printed and a crown can be manufactured or such on it. But with photogrammetry, you're getting a much more accurate decision on where that implant is, correct?
Much more
because of the scanner. Yeah. And that scan isn't really capturing the gum tissue or the other teeth. It's capturing exactly where that particular implant that you've asked it is relative to the other implants. And that accuracy is important when you're trying to, there's a lot of stuff on the market, and maybe you can kind of give some insight. I personally feel like no matter how much you're stitching those pictures together, there's going to be enough inaccuracy so far, or the piece that attaches to the implant has to be so big to get an accurate representation of where it is, that it's sort of non-functional to take a full arch intraoral scan with those scan bodies. You know all of those different components that are available?
Yeah.
Do you like any of those?
No, I think if I can just be transparent, the best, I mean, Wes could tell you this as well, the best technology on the market in photogrammetry, which is technology that's basically taking a series of pictures with different cameras on one device at different distances, and it tells you the angles and everything, and the algorithm puts those images together and basically coordinates a XYZ coordinate for each scan body. So there's really two main technologies on the market that do that exceptionally. Well, there's three. I would say there's Micromapper, iCam, and PIC. There's other ones like Tuple, but you run into issues if you have more than 4 implants. There's the repeatability is not there. I mean, there's the quality's not there, in my opinion. It's not just because we don't sell it, but it's just not quite there. But you guys have iCam. We were the number one distributor for iCam until we developed the Micromapper. iCam is great. Micromapper is the best all around because accuracy, iCam and Micromapper are going to be relatively similar, and it's going to be in the neighborhood of, say, call it. I mean, we've gotten scans as low as like 9 microns of accuracy across 6 implants, which is unheard of. But that's in that's on a model. That's not on a patient. And then it'll go up to, say, 60 if scan bodies are used a lot with Micromapper or even iCam. You're going to be in the 60s. But the
thickness of a piece of hair is 50 microns.
Yeah.
Just so we can use that as a point of measurement, what Patrick's speaking to.
I didn't know that was 50 microns.
Yeah, we're talking microns are so. Now, just put it this way: if you want to, you'll see claims that people have photogrammetry devices or intraoral scanning scan bodies that you can stitch together and scan and get within 6 microns. You cannot even calibrate a machine and tell me if something's in a certain position like 6 microns of accuracy. It's so hard. One of the things we've tried to do different there with Micromapper is there's a calibration device in Toronto at Clarinav's headquarters that manufactures the Micromapper. They have a big long granite slab table that's huge, and that prevents like heat change or temperature changes, which can throw off the scans and throw off the calibrations. So this is one of the most controlled environments, and they can get it down to around 6 to 8 routinely. So that's just the test if something's within an accuracy specification. So it's hard to say, it's impossible really for any other photogrammetry device to say, hey, we're getting 6 microns of accuracy every time. That's just not happening.
Right.
So it's not. But yeah, so photogrammetry, that's given us the XYZ coordinate, as Wes mentioned. That gives us the implant position. The intraoral scanner is, for those that aren't in the industry or aren't clinical, it's the same as if you take a pano image on your phone and you have that arrow in the middle. You have to keep in the middle. If you move too fast, it goes up. You have to slow down. You go too slow, it goes way down. So you have to have it just perfect. Intraoral scanning is the same thing.
It is the same. I never made that connection.
It's the same exact thing.
Yeah, because you're just stitching a bunch of images together.
Yeah. So you think about the oral cavity, patients moving, assistants moving, tissue stretching, there's saliva, there's blood in some cases. It's very difficult to use an intraoral scanner to capture implant positions more than 1 or 2 implants. Like you said, if it's for single implants, relatively you can get it accurate enough so it fits. It's not an issue. It'll never be a problem. But when you go to a full arch, cross arch stabilization of a restoration that we'll talk about, whether it's milled or printed, to get that to seat perfectly, you need to have photogrammetry to have repeatability and predictability.
And so to parlay on your panoramic image that you take on your iPhone, everyone can understand that when that's stitching actively together, when something moves, you have somebody that walks through the background, it gets all distorted. Well, when that person's image is what you're trying to get, be it your implant position, and you're doing it with an intraoral scanner, it doesn't matter what it is, it's always going to look distorted.
To some degree, you're always going to have distortion. Mm-hmm. Like a lot of offices use bone fixation screws. You don't at Done & One. If you use bone fixation screws, when you go to do the matching, the post-op, so you put fiducial markers, you'll put these bone screws in the midline of the palate, 2 on each retromolar pad. You'll do a pre-op scan and the proper vertical. And then post-operatively, in theory, those screws have stayed the exact same place.
In theory,
all the way through the process, through the surgery. And if there's any movement, there's distortion, and the bite, midline, or cant's going to be off. The implant position is never an issue because you're using photogrammetry, which doesn't care about the distortion because it's capturing a real-time XYZ coordinate up to, call it 50 microns of accuracy. Intraoral scanning is not near that accurate, and you get that distortion. So, yeah, you have to make some adjustments.
Blake, have you ever done a case with fiduciary markers and fixation screws as a reference point for before and after?
Yeah, I found, workflows I've done before with intraoral scans pre-op, like you talked about, putting it in the palate, retromolar pad. It works, but they can move. It's another area of discomfort for the patient, but it's a different protocol than we use.
I did it a bunch way back in the day. I think I even did a couple cases when you came and visited us one or two times. Beside the workflow interruption, which is I have to put it in and then we have to wait for the scan and then we have to come back, the fear as the person responsible for the care of the patient, the overlooming fear of disrupting that fixation screw, I always felt like got in the way of clinical decisions. I was not compromising my care, but I was making clinical decisions around these 4 or 3 or 5 little screws. And that always felt very uncomfortable for me because you would get to all the way to the end maybe, and it did move and you can't do XYZ that you were planning on. But not only that, the decisions were somewhat compromised because I'm altering what I'm doing based on that screw's in the way. Now I can't do this. And that was always very frustrating. That was probably the number one reason why I started as an all digital guy, all digital workflow, and then bounced back to being a mix of analog and digital, was because that to me is not a solution. That's just introducing additional problems. That's just my take on it.
I see it all the time where like the distal sites on the mandibular arch, you would go to place your angulated distal implant and your contraangle handpiece would hit those screws. So you'd have to change your insertion direction of your drills, which sets the tone of the implant position, the multi-units, and the teeth. So
it gives me palpitations to think about it, honestly. It scares me.
One thing I wanted to ask you, Dan, is you've gone through all the workflows, analog, digital. When you switch from scan bodies to, let's call it flags or scan bodies for photogrammetry, what did you see difference, the difference clinically for your patients?
Well, I'll go back a little bit further. So when I first started doing hybrids, we were not doing zirconia as the predominant restoration. We were doing a cast bar with denture teeth on top. And that was before any of this real technology was available. So we would take a physical impression, we would take that physical impression, put it in and pour it up and turn it into the stone that everyone is used to seeing. And then you have to connect that with a very strong plastic bar, if you will. The lab will make you a strong plastic bar. They cut it in a specific way where they're each individual, give it back to you, you put it into the patient, and you re-glue it back together inside that patient to it's called a verification jig. You do the verification jig to make sure that those implants are exactly where your impression said it was. You then take an impression over that. You go and you can take an impression over that. But you would take that back to the model. You would look for any differences. You cut that out of the stone, re-pour stone in that particular area and you kind of would guess, right? Because if you did 4 implants and one was off, you had to have somebody that really knew what they were doing to tell which one was the one that was off, because one is going to throw the whole system, and you have to have that eye for really which one is the one that didn't make it correctly. But long story short, when you would finally get to the end, that was just done by hand and by stone, and stone expands and contracts and expands and contracts and has different levels of accuracy. And so the result wasn't that accurate, to the point that when we would do a zirconia off of that type of way, you almost had to wince and be a little bit concerned as you were tightening these screws in. There was a chance that they would be off enough that it would break the zirconia. And that's even with, and we still use titanium bases for a pretty specific reason, but that's even with titanium bases holding the screws in, which gives you a little bit of play. Isn't that the intention? That's the intention of the titanium bases was there's a metal piece that's touching the abutment. There's cement that's kind of your fudge factor. And then there's this unforgiving zirconia. And the problem was, even in the most controlled scenario, when you screw that in, there would be enough off that you could break that cement, which was better than breaking the teeth, but it would be broken loose and it would be floating the entire time. So then with the advent of photogrammetry, we were able to instantly have a digital file that gave us that really close estimate or that really close number of where that implant sat, which allows you to seat zirconia with repeatability and a peace of mind, etc.
Passively, have it fit passively.
Yeah.
And the analog way too, if everything doesn't line up, not only can you fracture the zirconia, but you're putting stress on the implant as well for the longevity of it. And
Wonderful.
You're going to get bone loss.
And that could be a whole nother 5-hour conversation, but that's the reason why I hate the zirconia bridges on top of the implants, is you can impart internal stress into those bridges, into those teeth, into those implants, and get a killing of the bone because it's too much pressure in one direction or another that ultimately the patient doesn't see until it's too late. And so the reason why we're in hybrids and the reason why we do the cases with the gum tissue and all of that is because when you assemble it all and you assemble the machinery and you assemble the accuracy, you get that very repeatable good result that you don't have to wake up at night and think, oh man, Mrs. Smith, I hope that her implants are okay. Like, you know that they're tied to that implant.
When did you switch over to photogrammetry?
So that's part of the story as well. So we got into zirconia and we started to switch over off of the analog into photogrammetry. We started in, I would say, 2017, 2018, right about when we met. And I remember I had negotiated a deal with iCam, with Horace, for maybe 3 or 4 of them. We had 3 or 4 offices. And Dr. David, my business partner, was talking to Pick Dental. And unbeknownst to me, when I showed up on Monday, I wanted to give him the numbers for the iCam. I was all excited about it. And he said, oh, you owe me this much for the picks that I just ordered because we just bought 4 of them. So that was already committed and down the road. So we went down Pick, and this isn't to bash Pick, but their flags are made of plastic and they're very, very big. So it's really hard in surgery to get the pictures of them. And you also can't determine whether or not they're deformed or not, truly. You kind of almost have to open a new package every time. But even then, patient accidentally bites down and deforms it. Well, what are you going to do? You wouldn't be able to see it. And so Pick, and it also has 2 cameras. Pick was really hard for acquisition. It was really hard on the patient. It was really hard for consumables and changing out those plastic pieces. And so I had a really, really bad first experience with photogrammetry, such that when I separated and moved on my own, circa 2019, 2020, I didn't do any photogrammetry. We went back to verification jigs because I was convinced that photogrammetry didn't work because of my bad experience. And then finally, over time, I forget what was the scenario, but that's when I went back into iPick or
iCam.
iPick is a movie theater right here. I went to the iCam because their flags are much more accurate, but they're made of metal. They can be reused. They're not disturbed by patients. The acquisition is good. And maybe in the future we end up with a micron mapper, but it's one of those things that has 1,000 different parts to it, right? Why we use it and what solution isn't always the answer. There's what goes into it for the patient's experience, what goes into it for the cost, what goes into it for the new computers you need to buy. Does it fit into the software? There's a lot of the things that kind of go into that whole ecosystem. And part of dentistry, there are some places that sort of make it Apple, where the ecosystem is on the iOS platform. And that's cool at first, but then you're limited. And
Like
so you want to
zircon's
grow
on.
out. Yeah, zircon's on.
Yep.
And so, yeah, it's all fascinating stuff. And to go back before, since we're covering a little bit of history, there also was a period, and some people do, if you don't have an intraoral scanner, or say don't want to invest in one, or the lab, not every single location has an intraoral scanner. The lab or the place that it gets scanned will have a tabletop scanner. And so that was basically like a standardized platform that had a camera that had a series of views that it would take. And you would scan it in, it would take 10 minutes.
Yeah, they're relatively quick.
Yeah, it was different data acquisition, but they're relatively quick, and it manipulates it in a way in which it can turn that stone model into a digital representation. The problem with that is that it's only as good as your impression. It's only as good as the shrinkage of your stone. And so a lot of the streamlining of this digital world has been focused on how do we limit the data inaccuracy. So you can use a micron mapper at 6 microns, but if your milling machine, you're doing it dry and with a crappy, really old version, maybe it only mills to, 50, or I don't know what the tolerance would be for.
So on milling machines, the tolerance, it's like for IMUS iCore, what we sell, arguably, we view it as best in class. They're going to be, with new burrs calibrated, you're going to be within around 20 microns of accuracy.
So to that point, the best micron scan doesn't even matter because you're only ever going to get within 20.
It stacks, actually. So your average scan, whether it's iCam or Micromapper, a good scan's going to be 20 microns of accuracy. So you got 20 on the photogrammetry. Could be off a total deviation of 20 microns. Milling, say, could be off a total of 20 microns. There's 40. Then you've got centering, which the papers are very rough on that. We've done some studies, but so Micromapper has what's called fit check. So you can take your zirconia restoration, you can screw on reverse scan bodies and scan that, and it'll tell you, compare it to the actual patient scan. So you can tell exactly what's in the patient's mouth up to 6 microns, okay? Then you can see exactly what the rest of the framework is and compare the difference of those two. That's the only way. Think about this. I know I'm going a little bit ahead here, but rewind back to 2017 when you guys were doing everything analog. What was the tool that verified if something was off?
The dentist.
Well, the dentist, yes, but what step
The
was
patient's
it?
mouth.
How did you know? It's usually
We didn't.
verification jig.
Oh, yeah, sure.
Usually the verification jig. So in a fully digital world, what is the verification jig? If you need a check, say if you're a mass production lab or you're a big implant center, you guys do a lot of cases, how do you check that?
Really, it's adding all of those equipment up to the zirconia and whether or not you're having issues at zirconia, which would be a negative because it's at the delivery.
Exactly. So what we developed is the fit check, and it's not for everybody, but those that understand what it can do, like for example, there's an office, a good friend of mine, he gets everything from us, milling machines, implants, you name it, photogrammetry. He called us and said, and he actually, before he had his milling machine from us, he had a zircons on. And he's like, something's going on. I've been using Micromapper for a year now, no problems. Now I'm having arches that are not fitting. And we're freaking out. We're like, oh, what's going on? What could it be? Everything's digital. We're like, it's photogrammetry. It's got to be passive unless maybe the scan bodies are off. So we checked the scan bodies. That's fine. They're seating them all the way. We looked at how they were seating them. Everything was going fine. Come to find out, he's like, listen, I want to buy a new milling machine. Maybe it's my mill. And we're like, the sales team's like, all right, let's get this done. And then, and I'm like, well, hold on. How could it be the milling machine? I know zircon's on well. It's not our product, but it's still a good mill. It just takes 4 hours, and the zirconia is through the roof expensive, and it's a closed system. So I see the cons, but it's still a good milling machine. I know Enrico Steger. I have a lot of respect for them. It's good zirconia, and as long as they're centering it properly and milling it properly, it shouldn't be an issue. Come to find out, that was the same month we released fit checkers, Blake parachuted in. He's like, let me figure this out. I'm going to fish out exactly what's going on. So he basically took on all the scans of the patient. He compared them to the 3D prints. There's obviously 3D printing is not nearly as accurate as milling. So you're roughly a 60 to 80, maybe even 150 microns max off. Okay, not terribly off, but this is consistently something's off. Went to the mill, milled out restorations. Obviously, on zirconia, it's milled at roughly 20 to 30% larger because you got to shrink it when you bake it. That's when it turns into a metal. So we milled out some restorations and then fired them. And we come to find out his centering furnace was not calibrated. The zircon's on. Had been calibrated in over a year. So it was distorting on the centering side. So he ended up buying the milling machine from us anyway. But we did surface the problem. It was the centering furnace. In the new world of digital workflows, there's no other way to verify. How can you pinpoint where the process is? Maybe they match the wrong exocad libraries. Maybe they put the wrong screw channel. I mean, there's so many different things.
So many parts.
So anyway, this is it's a tool that, it's a little bit of a plug for Micromapper, but at the end of the day, I hope more companies develop these for their scanners because it's something that's a needed tool in this new environment of digital.
Yeah, because you always want to know where your problem comes from, whether it be a business or manufacturing or whatever it is.
Not only that, when the patient comes to receive their final teeth, you don't want them to be disappointed when they don't fit properly, and now you're back to the drawing board, and it's not a good day.
Absolutely.
Yeah.
It's funny because we were talking last time about how exciting this is for me because it's putting all these pieces together allows for this whole new world, and it's more stress free and all of that, and it's very like peace of mind. And similarly, you can do this the old way as much as you want, and it works fine. It's within the boundaries of it works, but it's only really like possible with exceptional results if you use good machines and you vet them out and you make sure that they're all, just as an example, you can't just buy the machine and think that you as a dentist are going to run it all by yourself because there's calibrations that need to happen. There's the dry heating and there's everything that goes into it, running the distilled water through to make sure that the machine is clean. So there's a lot that goes into it, and it's a whole team that comes together to make this possible. But when it's possible, the accuracy and the results are so bulletproof that it's just a very straightforward type of process.
Yeah, and I think with your culture and what you've done with your team, like many of your team members I've known since the beginning, since I met you, which is that's what it takes, a team that's close, that works together, and you need people you can depend on to cover their end of the pie, so to speak. And it's good to see that you guys are all still together.
Yeah, but you got to be a team to bring in those good results.
Although we don't get to see Nick today, unfortunately.
He's probably working very, very hard. He's a busy bee, especially with Jacksonville opening. He's a busy guy. So parlaying into manufacturing, more from the data acquisition into manufacturing, Blake, describe to us the different types of manufacturing that you can main manufacturing for dentistry.
Yeah, so we've thrown around a lot of words so far. We've talked about zirconia, we've talked about resins. So to kind of go from the beginning, you have additive and subtractive. So additive, think you start with nothing and you're 3D printing something. So that's going to be 3D printing, anything that's going to be out of a resin, more of a temporary material, like night guards, temps, acrylics, things like that. Subtractive, we're going to see this in full arch when we actually mill zirconia. That's going to come from a puck. This is going to come from a substantial material, and it's a different process. It's
pre-manufactured prior to bringing in your dental file, if you will, versus sort of, like you said, comes out of nothing. It's manufactured with some sort of material. The material can be a goop with a light that comes from the bottom, and it's not accurate enough. But the other type of additive manufacturing that's popular in printing is it's almost like a hot glue gun. That's what your main hobby ones are. And there's a lot of advantages and disadvantages to the two different types of 3D printing. But the main advantage for dentistry, and the reason why we use the ones with the vats of goop and the light that cures it, is because of the accuracy mainly. If we were able to ever get to an additive manufacturing where it was more like your hobby printers, it's, a little bit more clean, it's a little faster. You have a lot more variety in material mixing colors together. And there's a couple companies out there that are starting to kind of break that trend, like we talked about. But for the most part, it's a vat of sort of, a matrix of goop is really the best way to.
Yeah, it's a resin, right? And the ones that you use obviously are all FDA approved. So that's the other limiting factor, is you need to have a medically approved restoration. That way patients some of the materials even approved for long-term use, what they would call a final. Not that I see it on every corner where it's being used for long-term, but you have to, it's a resin. And what happens is there's a build plate that comes down from the top, puts pressure on the goop, as you're calling it, which is the liquid resin, in a tray, and the tray is a transparent bottom that flashes UV light in a certain shape, and that's what's going to be cured on that one micro flash, and you get like a small layer. And most of these printers are around 50 microns of accuracy, so it's a tiny 50 micron layer relatively, and there's just multiple layers. So by the time you're done with your print, if you look at it before you cure it, you can see the lines and the layers that were added on top of each other.
Yep. And it makes it so it's a little bit more solid too. When you're I do a lot of like hobby printing. I have a couple of hobby printers at home, and you can see the layer lines because they're not as accurate, and they also don't seal together as well. When you're doing that resin, it has a tendency to seal in that whole structure, that whole surface.
Can you elaborate? Give us some ideas of what you've milled or printed at home?
Oh, all kinds of stuff. Right now, currently, what I'm working on is, when you're fishing, you have different lures, right? And different lures will hit different fish at different times. Maybe it's light out and they want a darker, they're starting to hit like dark purple or the white ones or whatever it may be, right? And so when you rig these up, it kind of takes time to rig them up, right? Well, you want to be making any second that an lure is out, and I do a lot of trolling, so it's dragging dead bait, if you will, 6 of them at a time. Any time that one of those rods is out of the water, you're not fishing. So I always struggle with preparing the right amount of bait and keeping all of the stuff organized, and like the line that's attached to the lure. And so, and you also usually put actual like ballyhoo or dead bait on it. And so right now what I'm working on is I've prototyped a system that allows you to organize the lure in sort of like this shotgun kind of grab way. So it's organized on the inside of a 5-gallon pail. You're like, man, I shouldn't have asked this question.
No, keep
but
going.
It's organized in a 5-gallon pail, and so it's essentially the top that holds the line of the lure and keeps it sort of pulled up with the bait. And so the reason why it's in a 5-gallon pail is because you fill it with like ice water, so that bait stays frozen and brined, but can also be like a quick switch out. So you can switch out when your bait gets hit and you have minimal downtime. And so for, several hours of my hobby time, but I've gone through about three prototypes that I don't really absolutely enjoy or love yet. But for about 60 cents a piece, 50 cents a piece at most, with about 3 hours, I can have them kind of ready to go.
So that brings us to the next part, which is the software. So what software are you using? And then we can go into dental.
Yeah, so I use, for the design, you mean?
Yeah.
So that's actually a genius little segue. So there's always a design software. The design software is what creates the CAD program or the file that you're going to be printing or manufacturing. And that file is kind of similar to Microsoft Word or Pages for Apple, so that it can be a little bit specific between systems. So I design my prototypes and things in a program called Fusion 360. It's the design program that really is the main engine for if you're going to build the new Ford engine and you're going to build a a piece that fits into the lid of a cup or something. It's one of the main design engines sort of across all industry and platforms. And then once you have that file made, you then need to put it into the machine that you're going to make this file on. So in additive printing, you need to put it through a machine that's going to slice it, and you put it in what's called a slicing software. And that slicing software, and Fusion has it built in somewhat, but it slices it to say, it's really creating the instructions on how to actually assemble and build. It's kind of like the Microsoft Word. When you go to prepare to print, it's giving specific instructions on the printer of where everything needs to go. It can't just duplicate it out of the computer. So there's two different really types of software, which is similar to the way that we use it in dentistry. And then if you're going to do CAD, I also have a CAD woodworking milling, an acrylic milling machine at home. And I can design in Fusion, but it's a different type of software. It's a different way to write the instructions. And those are very different in additive and subtractive.
So it's computer-aided manufacturing, so CAM. That's the CAM software.
Yeah, exactly. There you go.
Yeah, very similar to your milling machine at your lab, but so you're doing subtractive and additive at home.
Yes.
Ah, interesting.
Yes, it's a big hobby of mine. That's why, that's almost kind of, I feel like that's why I kind of got into hybrid dentistry, is because it really just like hit all of my favorite little hobbies and niches. And what I love about it as a hobby, just as a little side note, is I love that, for instance, like we had the tropical storm that rolled through here. So there's a ton of rain, we'll say, on Sunday, right? Well, I got to go play part of my hobby. Even if I'm on vacation, I can be designing something on my computer. I don't have to make it right then. I can bring it home, put it on my slicer, put it in the machine, actually make it, or send it across the country to be printed. But what I love about it is it's a hobby that's sort of independent of location and weather. So it's a hobby that I can do. I don't have to check the waves every day to see if I can go fishing, or check the wind and see if I can golf. So it's a hobby of mine that I can do in my idle time in a waiting room or whatnot.
Yeah. So with when it comes to dentistry, we've got exocad is the predominant CAD software globally for full mouth rehabilitation. 3Shape, you can get through it. You'll have less hair than me, which is not much, if you stay in 3Shape. It's a great software for singles, dentures, a lot of other restorations, but full arch fixed restorations using photogrammetry and stitching meshes together, exocad is by far the best, no questions asked. We can, Wes asked me, I think you asked me this yesterday as well, what's the latest with AI design? Has exocad mentioned anything? Well, the head of exocad was actually at our headquarters recently, and then our team was on the phone with him in Germany about some of those advancements. They already have AI design for single crowns, meaning you upload that intraoral scan body from the intraoral scan that you did, and within a few clicks you can have a crown generated, and you can toggle back through different libraries for different morphology or shapes. When it comes to full arch, it's not there yet. We are working hand in hand with exocad to help support them as fast as they can. There's another company that we're working very closely. There's two other companies. So it's not something we want to bring in-house, but it is something that if somebody comes out with it, great. We're going to, as long as it works, we're going to promote it. Even if we don't sell it, it's something the market needs, the patients need. It'll increase that time and result. But exocad is what basically takes all your files, your photogrammetry file, your intraoral file, brings them in, allows you to stitch a mesh, which is an intraoral scan of a patient. When you bring in an exocad, it comes in the form of a mesh. The implant position file is another mesh, and you basically start stitching these together along with the teeth design. And there's prefabricated libraries in exocad. Zircon Zon's got a bunch of libraries. There's a number of libraries out there you can import into exocad. So then you adapt the teeth libraries with whatever design library you want, and then you stitch that to soft tissue scan, the implant position, and the opposing arch, and then you take that file, you export it. I'm simplifying this.
Oh, yeah.
Yeah, Blake Roney, he runs our exocad team. He was actually just at Nova, I think a week ago, or two ago, teaching them. He was at UNC last week teaching the pros there on exocad. He's arguably one of the most educated guys when it comes to exocad globally that I know of. But he'd probably slap me on the leg for talking about exocad like this. But but that's how I view it. It's a file organization tool that allows you to customize, make some designs, and then export that STL to what you were talking about, Dan. You can go to either a 3D printer, or you can go over to milling machine. So like to Blake's point, additive and subtractive.
Yeah.
So.
And different materials have the different uses. You know, predominantly currently, printing and additive manufacturing is used as a temporary prototype, however you want to say, whether it be for a crown or a full arch. It's used as a definitive for night guards. What else is it definitive for?
Single unit crowns.
Single unit crowns.
We see that pretty common for not necessarily you're in the main aesthetic zones, but in the non-aesthetic zones, we do see those pretty common.
Guides, surgical guides.
Surgical guides.
Yep.
Model bases.
Models. Yep.
Yep. Yeah. And then the subtractive is generally where we're finding most of your final materials. It takes it's a little bit more time intensive because you're taking the final material and cutting away from it. And there's usually a little bit of post-processing because there's a little bit more post-processing because depending on the material or how you're going to finish it, it can take a little bit longer to get it to its final result. So it's not as convenient as a temporary. It's a little bit more expensive materials. And that it all works out pretty well in the end. But you know, the tech has come a long, long ways. I mean, as I said here, my career is not that long, and I started with doing cast bars were not even cut on a milling machine. Cast bars were you make it out of glue and sticks and super glue and tape, and then turn it into a metal version. It's been a pretty wild career so far, and the changes.
When you look at accuracy, time, and all of those things, I always say technology never has a bad day, right? It's not in a fight with its wife. It's not lack of sleep. It's going to be spot on every time, where in the analog way, there's human error that's involved in all of those things that can change depending on the circumstances, whose hands it's in, it acts different, where the technology is, it's repeatable, and you can rely on it to do that every time you go to use it.
Yeah, you're only as good as the machines you use, and you're also only as good as the hands that are used in it as well. So that the two combined can be a big problem or perfect result.
Yeah. Yeah, we've seen, so back when you first started with Zircons on, it was roughly 3 hours, 45 minutes to do a zirconia arch. Nowadays, we've seen, actually, I just pulled up an image from last week. Blake Roney just sent, we're at 1 hour, 8 minutes for a full arch.
Sintering.
No.
Milling. That's great.
So timing is coming down. Now, a lot of that has to do with the machines, has to do with the Hyperdent, the CAM software, has to do with finishing roughing burrs. So now they're making a lot bigger burrs because full arch is becoming so popular. They'll come through with a big 4mm burr. We have a 4.5 that's coming out that it goes through and just mows down all the excess zirconia. So then the fine burrs can get in there, and then you usually have what they call a C-clamp. So on the subtractive manufacturing, it'll allow the access of the burr to go directly on the front of the tooth, so you can get good details on those anterior steps.
As opposed to being all the way around the material.
Yeah, top and bottom only.
Sure. The as we kind of get to sort of towards the end, how do you think, being that you guys are so exposed to other dentists and offices, I mean, Patrick is one of the most prolific in terms of knowing people in the industry of full arch that I know of, for sure. You might be number one in terms of person that also knows that many full arch people in America. I mean, can you think of anybody that knows more people in offices than you?
Not on the full arch side.
Yeah, I don't think so. At any rate,
Yeah.
I have a random question for you. So, as the other night I was watching television, and there was a very locally made television commercial that was a local office, and of course, they're touting their technology because they think that that's what all the old people want, is just more to see more screens, etc. And so they're talking about super accurate printers and super accurate scanners and all of this. And I'm looking at the equipment. I'm like, well, that's not that accurate, and that's terrible. And I used that 8 generations ago. How do you think of an office differentiate itself? Because now it used to be you had a printer, you were like one of the whole coast, and then it was one of the state. And then, how do you think that how do you inform the public to discern a little bit into like that there's a differing level of quality between an office that is advertising for, this scanner and they have all of these pieces of equipment, and maybe another one that has better equipment and better technology? Are we going to run into this scenario? The way I think of it is my father is in the printing industry, and they print millions and millions of Bibles per year. And the printers that they buy come from a specific, place in Europe, and takes 10 years to end up getting and calibrating and perfecting, right? And the Bibles that they print on, the paper is so thin you wouldn't even be able to touch it without pulling it apart, kind of thing. Versus, I have an inkjet printer at home. I can advertise that I'm a printer, and so can he. What's the scenario there? Like, how do you that we can all think of like, okay, well, his is better because we can see it and it's better. Whereas, like, as a person that's in the industry, it's hard for me to differentiate.
Very
hey,
much.
I very much care about the accuracy. This guy just bought the one that was on the sales floor. How do you see the industry going in terms of technology and using that as a marketing sort of ploy? And it may not have an answer.
It's tough because technology is only coming at us all faster and faster, not just in dentistry. But when it comes to full mouth rehabilitation, it's, I wouldn't say technology is just they need to use certain technologies to have a certain level, kind of like your thresholds. You have certain thresholds, otherwise you won't even look at it. You won't even entertain it. Once those are met, after that, it's not more technology is equals better. It's, so once you're using photogrammetry, once you're using CAD softwares, once you've eliminated the analog steps, on the verification JAG impressions to increase your accuracy. The next things are more the intangibles on, like, going to your assistant, asking her the questions, because they're in for a consult, or when they go to see the office, or maybe if it's over the phone, it's asking the uncommon questions that you could probably find out the most for a practice. Yeah. For me, it would be, I can learn so much about the employees of an operation. I can learn so much about the clinician if I understand the employees, understand the culture, how they're treated, how educated they are. Do they know what's going on? Like, I can walk into any dentist's office in this neighborhood or any state, anywhere, and ask, okay, I need a crown. How much is a crown? How much time is it going to take? And, what steps are involved? Almost everybody, even front and back office, can tell me. But if I'm a full mouth rehabilitation patient and I need a full mouth done, I can't go to every office. Not everybody can answer those questions. So in your practice, I could go to any one of your assistants, pros or surgical. I could go to your lab techs. I could go to your business partners. And everybody's on the same page. That's the big differentiator. So how a patient takes that and executes on that when they're in their journey for treatment, it's somewhere in that neighborhood. Because I think about it if I have to go see a cardiologist, how do I translate what I know? It's very hard.
I always tell patients, I don't envy you having to make this choice.
Yeah. And I think patients are smarter now than they've ever been because of the access of information at their fingertips to do their own research at home. Not too often, probably when you see a patient, it's their first consult, right? So nowadays is different than what it used to be, of putting all of the trust in the provider, the clinician, to kind of tell them the ins and outs of the technology or how they go about stuff. I see now, especially in the younger generation, even the older generation, with the access that we have to the internet and AI and things like that, we can find out a lot of this information at home, where now they're coming to you and they're asking you very educated questions.
Yeah.
And some of those educated questions revolve around products or this type of technology or different brands or things like that. So it just goes to show the awareness that they have and the accessibility that they have to it.
Absolutely. And that can be to the positive or to the detriment.
100%.
Yep.
Yeah.
Sometimes they feel like they know too much and it's really not something that matters. And sometimes they don't know, or they know just enough.
Yeah.
I'd say in general, though, I'm grateful for there being like a company out there that's pushing the big marketing, because they're raising the awareness, and they're where people go to for the first consult, and they kind of give them that first tweak of, maybe that's not the right place for me. Maybe I don't really want it to be so streamlined, herding cattle kind of scenario, or whatever it may be, but they're bringing up the awareness, and so is the technology. Even if it's to their detriment, that gives you an opportunity to educate them and say, no, that actually doesn't really matter, and here's why. So it's kind of nice, because you're on a limited platform of, these are all the potential questions and education that you have to be down. But when I first started doing this, it was an hour and a half of discussing all the different options that might work for this person. And so they only get little tiny limited windows of each thing, and maybe had never heard of it. And it was so hard to sell a case back in the day, because there was just so much nothing out there, rather.
And educating from scratch.
Yeah.
Mm-hmm.
And talking about experience and how long you've been in the game doing this, and how you've seen the changes in the industry, and how you've crafted your skills to adapt to the different changes in the technology and with the industry. I think from someone like myself, when I go to buy something and I see the experience the person has, or the confidence I get of, oh, they've been doing this for a while, and, hey, this is our lab that we have. We do all of this in-house. Things like that are really kind of like a wow factor. Like, this office knows what they're doing. They've been around the block a few times, and, when it comes time for the surgery, they've probably seen the things that can go wrong. They've probably seen them before, so now they know how to mitigate those, or to kind of work around those things to get to the end point.
Yeah, absolutely. It's I guess the best advice is keep your ears up, and if something feels kind of weird, maybe you should find somewhere else.
Nothing wrong with a second opinion.
Yeah, absolutely. Well, speaking of second opinion, I appreciate you guys coming in and giving me your second opinion. I've had a good time catching back up with you guys and conversing about some of this is sort of where my passion lies, is in the manufacturing and the streamlining and just how that whole flow works. So this has been fun discussing that, and the macroscopic stuff with implants and et cetera. So appreciate you guys. I know you got a flight. So if you're listening, watching this, subscribe, come on, join. We'll have a lot more episodes with a lot more content, a lot more visitors, just discussing kind of things with dentistry and patients and the good, the bad, and the ugly. So we'll see you next time.
Thank you.
Thank you.
Thanks, Dan.